See this problem. For a circular coil of radius r and n turns carrying current I, the magnitude of the magnetic field at a point on its axis at a distance x from its center is given by B is equal to mu naught I r square n by 2 into x square plus r square whole to the power of 3 by 2. Show that this reduces to the familiar result for field at the center of the coil. Consider two parallel coaxial circular coils of radius r and number of turns n carrying equal currents in the same direction and separated by a distance r. Show that the field on the axis around the midpoint between the coils is uniform over a distance that is small as compared to r and is given by B is equal to mu naught into Ni by r into 0.72 approximately. Such an arrangement to produce a nearly uniform magnetic field over a small region is known as Helmholtz coils. Our motive is, from the textbook we know that the magnetic field at a point on the axis of a circular coil can be represented as B is equal to mu naught I into r square by 2 into x square plus r square whole to the power of 3 by 2, where I is the current flowing in the coil and r is the radius of the coil and x is the distance of that point from the center of the coil. So this is the general formula for that. If the coil contains n turns, then the field value will become B is equal to mu naught Ni into r square divided by 2 into x square plus r square whole to the power of 3 by 2. This is what the expression given in the problem. Here two questions are there. Need to find out two things. One is the field at the center of the coil. So if the coil is here and we got an expression for the magnetic field at the point which is on the axis. If you bring this point to here, it will become the center of the coil. Here we need to find out the magnetic field, that is B naught. And one more, second question is, we have been given two coils like this which are placed such that their centers lie on a axis, and at the midpoint of this line we need to find out the magnetic field. So two things we need to find out. Now I want to investigate the problem. Okay, investigation. It is given that B is equal to mu naught Ni r square by 2 into x square plus r square whole to the power of 3 by 2. This is the field for a point which lies on the axis of the circular coil having n turns. So here for B naught, look at the figure. So here the point lies some x distance from the center of the coil. If the point brings to here, the x value becomes 0. So if you put 0 for this x, you will get a mu naught Ni r square by 2 into r square whole to the power of 3 by 2. So if a power m whole power n is equal to a power mn, then here also r square whole to the power of 3 by 2 can be written as r power 2 into 3 by 2. 2 gets cancelled, you will get r cube. That is equal to mu naught Ni into r square by 2 into r cube. R square and 2r terms will get cancelled, so you will get mu naught Ni by 2r, which is the familiar formula for us while solving the problems. So this is problem A, and we need to find out the second one, that is B. We have two coils like this, and these two coils are separated with a distance r which is similar to the radius of these coils, and we need to find out the magnetic field at the midpoint of this line. The currents in those two coils are same, and radius is also same, and if A is the midpoint, then the distance from center of any coil to the midpoint is r by 2, which is called as x in our previous problem. Now consider the field which is due to the first coil. Consider it as B1, and B2 is the field due to the second coil. So if you hold this coil with your right hand, your field direction at A will be towards the first coil, and if you hold this also, it is towards the first coil only. So the total magnetic field at A is equal to the sum of B1 plus B2, that is equal to, both are same because coil current is same and radius is also same, and the distance that you are considering from the coil is also same. So B1 is equal to B2, so you can write 2B1, that is equal to 2 into mu naught Ni into r square by 2 into x square plus r square whole to the power of 3 by 2. 2 gets cancelled, and we can substitute x value here. X is r by 2. So mu naught into Ni r square divided by r by 2 whole square plus r square whole to the power of 3 by 2. That is equal to mu naught Ni r square divided by, this term will become r square by 4, and if you take the LCM, you will get to 5 r square by 4. So 5 r square by 4 whole to the power of 3 by 2. If you bring out the constant, you will get mu naught Ni into r square by 5 by 4 whole to the power of 3 by 2 into r cube, as we seen in the previous explanation. That is equal to r square, and 2 r terms will get cancelled. You will get 4 by 5 whole to the power of 3 by 2 into mu naught Ni by r. 4 by 5 whole to the power of 3 by 2's value is 0.72 into mu naught Ni by r. That's what we need to prove. Hence proved.